Okay, so today we're doing our cumulative review for the cumulative test. One of the things you needed to learn was how to get the clump alone. Do you remember me saying that dumb little statement? All right, let's see if you remember how to do it for this. Absolute value of 2x minus 3, absolute value minus 7 equals 21. Everybody solve that one. First, get the clump alone. Then, once the absolute value is isolated, you can split it into two equations. I'll pause for a second while you try that one. All right, we're back from the fire drill. And that red one there, you'd start by adding 7 to both sides. That makes this 28, right? Now we split it up into two equations. The equations are identical, so I have this new way of doing that I really like. 2x minus 3 equals 28, and 2x minus 3 equals 28. You make them identical, and then you go, well, that'd be kind of dumb, because they're identical, so why do them identical? That one has to be negative. Okay, so that's the only difference between those two equations. All right, now I solve them, and I add 3 to both sides. This will be x equals 31 halves. And over here, I add 3 to both sides, but negative 28 plus 3 is going to be negative 25. And divide by 2 will be x equals negative 25 halves. That one and that one. Raise your hand if you had those right. All right, good job. And the next one, we add 1 to both sides. So I start by adding 1. That goes over here, plus 1. Now I've got the clump alone, and I can square both sides to get rid of that square root. Now here's where a lot of people will screw up. 2x plus 3 is all alone. Most people know that, because the squared and the square root just cancel each other out. But over here they'll say, oh, x squared and 1 squared. Doesn't work that way. X plus 1, and that makes first outside, inside, last, x squared plus 2x plus 1. Then you subtract 2x from both sides. And that's weird that 2x is just going to go away. 3 equals x squared plus 1. Subtract 3 from both sides. 0 equals x squared, and I subtract 3, so it makes minus 2. Can I factor that? No. So sad that that didn't factor, because otherwise I could do it really easily. But if it won't factor, because 2 isn't a perfect square. If it was like 4, it would have been awesome. But now I can do the quadratic formula. That'll get me my answers. X equals negative b. Wait a minute, there's no b term. So what do I put? 0. Negative 0 is just 0, right? Plus and minus square root of b squared, just 0 squared. Minus 4ac, 4, and a is 1, and c is negative 2, all over 2a. 2 times a is 1. Notice that the only thing that's weird about this is b is 0. That's the only thing that's really weird about it. Yes?
Can't you just add to both sides?
Yes, there is another way. Hold on just a second. Let me finish this. And then I'll see if your answer and my answer are the same. So we have x equals, and then 0 is just gone, plus and minus the square root of 4 times 2 is 8, all over 2. And I'm really close to done. Can I be done right there? No, because the square root of 8 breaks up. The square root of 8 breaks up into two things. Root 8 is root 4 times root 2. Okay, and I don't forget the plus minus, all over 2. And that's really plus and minus 2 root 2 all over 2. And then the 2's can cancel. So x equals plus and minus the square root of 2. There. Now there is another way to solve that. But I've told you so many times that if the thing doesn't factor, you should just use the quadratic formula, that I wanted to show you that way, because that is the way you use the most. This one, because it doesn't have a b term, it's true, I could have solved this part right here. I could have solved this quicker by going like this. X squared minus 2 equals 0. So x squared equals 2. So then square root, x equals, and this everybody forgets, plus and minus. See, and the thing I like about doing this is it's got the plus minus built into the answer. You know what I mean? Whereas here, I'm telling you, so many kids forget that plus minus. They just say the answer is the square root of 2, and it's wrong. It's plus and minus the square root of 2. Either way you get the answer. This way, because you got the thing built into the formula, you won't screw up the plus minus. Either way works though. All right. So I hesitate to even ask, because that had lots of steps and we had a fire drill. I don't know if you finished it or not, but anybody get that before I did? You had the answer already? Nice. Bunch of you. You're probably my A students. Nice work. And if you didn't handle that, that's what pre-calc is like. There's just, none of that was incredibly hard. It's just a ton of steps. I mean, look at from the beginning to the end. Holy crap. And that's what pre-calc's like. You can't afford to make little mistakes all the way through. And as I hand your test back, you'll see a lot of you made little mistakes. You screwed up on a negative in your proof of that there was a neither for a lot of you. And if you don't have it written right, you haven't proved anything. You just proved that you multiplied things wrong. And of course it'll come out to a neither if you multiply your negatives in wrong. So anyway, you had to have proved it correctly, and so many times kids mess up their negatives. All right, so that's one thing that's on your cumulative test. Let's look at a few other things. I think what we can do now is I'm going to hand back this cumulative review thing, and I'll do a few problems from it with you. All right, so I'm going to pause for a second while I hand these out to you. This is the cumulative #1 review coming out. Okay, so if you look at the front page of the review packet, the kind we haven't done yet are the ones with like the less than or equal to's on them. Let's do number 6 together. Everybody look at number 6. You should not be on your iPad right now. You should be on that piece of paper I just handed out. X cubed plus 2x squared is less than or equal to negative x. Put that away. This is math class. All right, so I'm going to add x to both sides, and you should too. Why did I do that? Because remember, when you get quadratics like this, you got to set them equal to 0. Quadratics have to be set equal to 0. Now I can factor something out. What comes out of everything? The x. And then what's left? X squared plus 2x. And now a lot of people just like say there's nothing there. There needs to be a 1 there. Otherwise, when you multiply it back out, what would you multiply the third thing by? There has to be a 1. All right, so I've now got it factored. Is it factored all the way? No, I can factor it further. So I go x and then factor this even further. And I'll have x plus 1 and x plus 1, I think. Right? Okay. So then, what are my answers? There's an answer for this. Think of it as having a parenthesis around it. It gets its own little answer. I set this equal to 0, so x equals 0. I set this equal to 0. X plus 1 equals 0, and then I solve it. X equals negative 1. And that's the exact same thing, so I don't need to do it again. So my two answers I'm looking for are this, and technically this is a double root, so there's another negative 1. But again, I don't need to list it twice, because I already have a negative 1. So now, I got my two answers. I'll pause for a second. Okay, so I've got 0 and negative 1. Am I done? No, and here's the reason you should know why. See how it's got a less than sign? Think of that as the end of a number line. That should be like the sign. You got to make a number line to get these answers. Because this is a range of answers that will be found on a number line. So you make a number line. And the number line goes between negative 1 and 0. And for sure, those are the two important points. And then we got to figure out where it actually works in all those different regions. This one has a or equal to sign, which means I fill in these spots. They work. What that means is these spots are zeros. They will make the equation equal 0. And if it's allowed to be equal to 0, then it works. Then I check. The hardest one is negative a half. Don't go back to the original. Use your factored. I'm going to put in a negative a half right here, and right here. Now, that's positive a half. That's positive a half. That's negative. What are two positives and a negative multiply out to? A negative. Now notice, I don't even care what negative it is, because all I'm doing is comparing it to 0. See what I mean? So as long as I know the answer comes out negative, I'm going to pause for a second. All right, so we have now got our thing tested for negative a half, and it came out to be a negative. Because 3 negatives multiplied by each other make a negative. Do you get I don't care if it's negative 16 or negative 200? I don't care. If it's a negative, it's less than 0, right? So it worked. So we tested this little zone, and it worked. And then you test for yourself to make sure like 1 does or doesn't work by sticking it in, right where I stuck in the negative a half. Stick in a 1. And you'll find pretty quickly that it comes out positive, and a positive number isn't less than 0. All right, so once you're all done, you write your answer using the parentheses and the brackets as in like this, -1 to 0. Oops, did say it wrong somehow. -1, comma, 0. There we go. Oh, what did I do wrong on my answer? Brackets, good. Okay. Okay, there is the front page. Now flip it. Do you remember how to do regressions? Linear regressions? That's on here again. In case you've forgotten that, that's a nice easy point. How about the number 10, the word problems? Those are always tough for people. My advice generally on the word problems, look at number 10 with me. I'll start it with you, but I'm not going to finish it. You have to do it yourself, otherwise you won't learn anything. Number 10, it talks about going up and painting a rectangle on the roof of your house in which you can write sky messages to your wife who is a pilot. You want to maximize the area of this rectangle. You know that you have enough paint to cover 320 square feet. All right, right before you get too far into the problem, I'm trying to draw a rectangle here. All right, so right away you should draw a rectangle like this. Yes? Okay, I'm going to pause for a second here. Okay, the question was on this last problem whether or not I had checked. I didn't even check this last one. I said you guys should check this and this area and see if they work or not, and then write your answer like this. And so yes, you should check and make sure this end or this end work. And I think you're right. In this weird case, I think another one of them works. So I'll let you figure out at home which one of those areas works. And if it does, then you got to add that to your answer. Okay, we're going to keep going here. I have a rectangle for problem 10, and it says that the area is 320. That seems important, but it didn't tell me yet about how long the sides are. So when you draw your picture, you have to label it, otherwise it's useless. So what do I know about the sides? You want the length to be 5 feet longer than it is wide. So you can either pick the length or the width to be your main side. I'm going to call this my width is my W. Then the other side must be, you should be able to do this, W plus 5. 5 feet longer than it is wide. Now, I have drawn and labeled a picture. I know you can all do that, and if you can't, you should find another class to be in, because seriously, Precalc is going to have tons of this. There's whole chapters of word problems. You have to be able to handle this. All right, next thing you got to do is write a formula that goes with it. Since it specifically said area, it's really clear that obviously we need the area formula. Sometimes they're a little more vague, and they'll say, like, the distance around the thing is this, and then you have to go, what is that? Oh, it's perimeter. So you at least know this time it's area. So area is, and what's a general form for area? Length times, or base times height is true, but length times width. That's the general formula. Now I stick in my numbers. I'll let you take the rest of this. And remember that if it's in a section that says graph it, like this one is, to solve graphically, then when you got your equation done, you're just going to graph both sides of your equation and see where they cross. It told you the area, you can write that in. You know the length from your picture over here, and you know the width from your picture over here. And you can, once you have that equation, you just have to graph both sides and see where they cross. Now remember, the last thing is, and people so often mess this up, you get it all done and you think the answer is 23. Make sure that's what they asked for. What did they ask? What length would maximize the size of the rectangle? Notice the question said what length, and kids a lot of times tell me the answer is like this, and it's the width. That's not what they asked for. They asked for the length. So if you come up with an answer of W is like 20, don't give the answer 20. The answer is really 20 plus 5 or whatever. Okay, so make sure you're answering the question they asked you. That's my general advice about word problems. All right, that should get you through up to the range. We already did range on our last test. On 15, 16, 17 on the side, next to number 15, write sketch picture. Because if you sketch yourself a picture, it's really easy to figure out the range. Once you have the picture for it on 15, 16, 17, it's so easy. And then 18 through 21 is all domain questions. Remember, we just care about the denominators and the square roots. So 18 and 19 don't have denominators and don't have square roots, so they can't crash. What's that mean about their domain? Negative to positive infinity, that's right. Because only things that have square roots and denominators can crash. So 20 and 21, those are the hard ones where you actually have to like solve equations, graph them, figure out what zone of numbers works. All right, that should get you through problem 21, and I'll talk about the rest of them on Monday. That's all I have for you for today.